Well, welcome everybody, and I want to assure you that this talk is going to be completely orthogonal to every other talk at this conference, which could be a good thing or a bad thing. I'll let you guys decide. And it was billed as big data and design where the magic happens. I also want to assure you I had nothing to do with that title, especially where the magic happens. In fact, what I thought I'd do today is be much more specific than big data and design, and share with you how and why at Intuit we're transforming our data scientists into design thinking leaders. And I also thought I'd go into some detail, if you'll let me, about the design thinking process that we're using to actually do our data science projects. Okay. And I hope that'll be helpful to some of you in case you want to take some of those ideas and learnings back to your organization. And it would certainly be cool if you do that. It'd be great to compare notes down the line, because I think we're all on the same journey here. How does that sound? You don't have a choice, but so here's the deep, dark truth about data science projects. If you define success as getting deployed and delivering the advertised business benefits, then data science projects have a very low success rate. How do I know? Well, I'm not aware of any direct studies on data science projects, but studies on big data projects show a success rate of well under 30%. And if you consider that data science projects are often on the bleeding edge, it wouldn't be surprising if their success rate was much, much lower. I also know, because I've been a data scientist for over 20 years, before there was a term data science, before I think it was the coolest job of the 21st century, or the sexiest job of the 21st century, which my children just love that. They get such a kick out of it. I've worked across academia, that's a flare up there, solar flare. I've worked across multiple industries, and I've led many data science projects, and I have observed many, many more data science projects. And I'd bet good money that across industries and across everybody who's self-described as a data scientist, the success rate of data science projects is below 10%. Anyone violently disagree? No? All right. So, I personally hate this waste, and I'm sure that many people out there also hate it. I hate the waste of data science talent, and I hate the waste of company money. Right? And I really think there's something we can do about it. So, here's my conjecture, and I'm way too modest to call this after myself, but if you want to do that, feel free. That's a joke. It's a joke. So my conjecture is that a data scientist can increase the probability of success for their project 5 to 10 times, I think, by approaching it as a design thinking leader. And notice that I say leader and not just participant, right? The good news is that design thinking leadership skills, I think, are eminently learnable. It takes somebody to walk you through the process and model the process for you, but I think thereafter, a lot of it is practice. So when I first encountered design thinking, a lot of the techniques actually sounded familiar, resonated, because I kind of stumbled on them in the past, didn't realize they were part of this design thinking thing. And what's great about design thinking, it was really eye-opening to see all these techniques brought together in a framework. The challenge, though, is that there are by now so many different design thinking frameworks out there, and so many different techniques, and it's not always clear how do these techniques map onto something like data science projects? What I wanted back then was somebody to say, look, here's a best practice, step by step, stake in the ground, design thinking process that's tailored for data science projects. And that's what I hope to share with you today. And I'm not presenting this as the best or the only one. I'm just presenting it as a minimal viable product that we're trying and we're succeeding with, and that maybe you can try as well. But before we jump in to the process, I want to make a disclaimer, right? I'm not saying that it's easy to transform data scientists into design thinking leaders. Because I think the key is that there needs to happen a mindset change, which we'll talk about in a second. Even at Intuit, where conditions are almost perfect for this change, it's really difficult. Intuit is a 30-year-old company. It's a spry, 30-year-old company that is actually reinventing itself from top to bottom using design thinking. We have a homegrown design thinking framework that we call Design for Delight, or D for D. Our Design for Delight process has 3 stages: deep customer empathy, go broad to go narrow, and rapid experiments with customers. And I'm going to unpack these later in the talk and tell you how we apply them, extend them, and apply them to data science projects. But the point I want to make is that we take design thinking very, very seriously at Intuit. First day on the job, you get a laptop and you get design thinking training, right? And then thereafter, your job performance is influenced by how well do you apply design thinking to your work. So there's this amazing organizational emphasis and widespread adoption of design thinking at Intuit, and data scientists have been participants in design thinking, in the design thinking process for years now. But what's different is that we're asking them to step up and become design thinking leaders. And I think it's challenging to persuade them to do so, partly because it's outside their comfort zones, right? We're asking them to step up and become change management leaders. We're also asking them to step up and go from playing an individual sport to a team sport, right? I mean, by and large, data science is an individual sport, and design thinking is by definition almost a team sport. So how do we help them make this transformation? So data scientists are a skeptical bunch, right? So the initial reaction to this idea that you should become a design thinking leader is, man, that sounds like something a product manager should do, right? And my answer is yes, exactly. So step 1 in my 12-step program is for the data scientists to start thinking of themselves as product managers for a new product, which needs to satisfy the needs of a very diverse group of customers. And I actually don't think that's a big stretch. Data scientists are often building new products. These new products might be one-time analyses for internal consumers to give them insight into some burning topic. The new products could be decision support systems, again for internal users to get insights on their own. Or the new products could be decision engines that automatically produce, for example, recommendations for external consumers, but new products. And the data scientist also serves a diverse group of customers. Who is a customer? Well, a customer is anybody who can derail a data science project. That's my definition. Right? So the primary customer, of course, is the consumer. We talked about them. But most data science projects also serve a wide variety of other customers, of other internal customers. So you might have the executive sponsor. You might have the software development team, you might have the operations team, and so on. And lack of strong support from any of these customers can kill a data science project. And this is not malicious. There's nobody walking around trying to figure out how to murder data science projects, but it happens because priorities change. It happens because resources are not available, and so forth. So my argument is that in a very real sense, a data scientist is a product manager of a new product that's intended to serve, has to serve a diversity of customers. Ergo, if you buy this argument, it's not inherently crazy to think that maybe some of the methodologies of product management could also be helpful in data science. But data scientists are, scientists, so they want to know a mechanism. Why exactly would design thinking help a data science project? And I think it works and it helps because design thinking attacks a core reason why data science projects fail, which is bad algorithms. It's a joke. It's not bad algorithms. No. I believe that data science projects fail mainly because of this. That to take a new idea and introduce it into an organization and get it accepted is extraordinarily difficult, right? It doesn't matter the scale of the organization. Maybe it's a little bit easier in startups. I don't really think so. But it's really difficult to take a new idea and introduce it into an organization. And data scientists are terrible at it. And I speak as a data scientist myself. I think introducing a new idea into an organization is like injecting foreign DNA into an organism, right? And what's going to happen, it's going to get rejected. And I like to think of the design thinking process that we'll talk about in a moment as taking this foreign DNA and transforming into something that the organization actually recognizes and accepts as part of itself. I think the design thinking process transforms my idea into our idea, and it transforms my project into our project. And by the way, that's eminently tweetable, so So on to the process. And I'm not saying that you should apply all this machinery that I'm going to describe to every project, but I found that even applying a lightweight version of the process is extremely helpful. I'm calling this design thinking plus because I've added some steps that are specific to data science projects, I think. The first stage in Design for Delight, if you remember, is deep customer empathy. And the goals of the data scientist in this first stage are to understand the people you're solving for, to understand the problem you're solving for them, to map the environment in which your solution must operate, and to define the characteristics of a good solution. Right? And it's very important to be self-disciplined in this stage, to not offer up a solution. Right? At Intuit, we have this saying that reminds us of this, which is, fall in love with the customer problem, don't fall in love with a particular solution. So during this first stage, the data scientist is a detective, right? Interviewing customers in the broad sense we discussed, and observing each customer, and then synthesizing what they've learned. In practice, what this means is that the data scientist is asking all the W questions, right? Customer, from your perspective, what's your role in the project? What problem do you think we should be solving? What's the rationale of the project from your perspective? What's your hopes and concerns around the project? What data systems, and processes should we make sure to consider? What criteria would you use to evaluate a proposed solution? And what criteria would you use to evaluate a deployed solution, right? All the W questions. And most customers in the broad sense, will really appreciate you asking probing questions because it helps them clarify their own thinking. Occasionally you run into somebody who's impatient and doesn't like that probing question about what's the business rationale. So in those cases, I suggest to the data scientist, one, take the time to explain what you're doing and why you're doing it. And then two, pull up the big boy pants or the big girl pants, as the case may be, and keep asking those pointed questions. The outputs from this deep customer empathy stage are 5 artifacts. And these artifacts synthesize what the data scientist has learned during their detective work. The purpose of these artifacts is to keep everybody involved in the project grounded throughout the project in the customer problem. And these 5 artifacts are the inputs to the next stage of Design for Delight. The first set of artifacts are personas. So each persona summarizes what you've learned about one class of customer. So obviously you have a persona for your main customer, the consumer, but you have also a persona for your other customers, your executive sponsor, your software engineer, your operations engineer, and so on. The second set of artifacts are problem statements. So each persona has an associated problem statement. And don't be surprised if this turns out to be a really hard exercise. But what I found is that if you craft good problem statements, then you're sort of halfway there to get into a good solution. And Einstein, for example, is supposed to have said, if I had an hour to solve a problem and my life depended on it, then I'd spend 55 minutes thinking about the problem, reframing the problem, and 5 minutes solving it. A good problem statement defines who has the problem, what they're trying to do, why they're trying to do it, what's blocking them from doing it, and how does that make them feel. And these artifacts, by the way, what I'm talking about is not writing War and Peace. I'm talking about just posters, right? The third set of artifacts, and ones that are really, really very important, maybe specific even to data science projects, are what's the environment in which your solution needs to operate? And usually this comes down to what data is available for algorithms and what systems and processes does your solution need to work with, okay? And systems and processes are so important because, guess what? They are extremely hard to change, right? So it pays off at this early stage to identify the parts of those systems and processes that are easier to change and the parts that are hard to change. The fourth artifact is, what are the criteria that are going to be used to evaluate a proposed solution. And remember, this comes from interviewing your customers. So don't be surprised as a data scientist if one of the criteria is that the algorithm has to be interpretable and simple. I mean, it's just human nature that people don't trust things that they don't understand and that they can't fix if they break, right? And this is often a bummer to data scientists, including myself, who love to implement the latest and greatest and most complex and most inscrutable algorithm, right? But it's better to find out about this criterion early rather than later. The fifth and final artifact are the criteria to be used to evaluate the solution once it's deployed, right? And again, don't be surprised and because we're interviewing customers for this, if customers want to know that the algorithm is working all the time, right? So not just from a one-time or periodic cross-validation, but they want to know it's working on a daily basis. Again, it's just human nature. And so don't be surprised if one of the criteria is, or the implications of this, is that your machine learning pipeline has to include testing, monitoring, and alerting from the very get-go. So we've reached the end of that first stage of design for delight. The second stage is go broad to go narrow. So this stage requires the data scientist to convene a diverse group of customers, again, customers in that broadest sense, and facilitate, as the design thinking leader, facilitate a brainstorming session, or more likely multiple brainstorming sessions, where you lead the group through generating lots of ideas, then filtering to identify the best idea, then taking that best idea and creating a solution hypothesis, and then devising experiments that will quickly and cheaply test that solution hypothesis, right? That's what we're trying to do here. And depending on the details of the data science project, there could be several brainstorming sessions, right? So one might deal with the user experience that's implied by your algorithm. Another one might deal with the architecture of the machine learning pipeline. And what I've found to be most effective is if these brainstorming sessions each last about 2 hours and have about 6 to 8 customers. Again, I'm being specific here to give you what I at least think is the best practice. So we've said that the role of the data scientist in the second stage is to convene a diverse group of customers and to be a facilitator for the brainstorming session. And again, this might rub some scientists the wrong way. What could a non-technical internal customer have to add to a discussion about algorithms? Well, they probably can't add anything about algorithms, but they do know the problem domain, and they probably know a lot about the characteristics of a good solution. But it's more than that, right? Having these customers in the broad sense, involved in the brainstorming session makes them feel like they have their fingerprints on the solution, right? And that makes them intellectually and emotionally invested in the solution's success, right? That's the key. So we're starting to go from my idea to our idea, and from my product to our product. Don't forget to tweet. I am kidding, right? So a really helpful first step in the brainstorming session is for the data scientist as design thinking leader to go over the rules of the road for the brainstorming session. And these are common sense things that we learned in kindergarten. It's incredibly helpful to have them posted up on the wall and be able to refer to them if somebody's not playing nice. The second step in the brainstorming session is for the data scientist to post all of those artifacts that were created in the first stage and to review them. Again, this is not a heavyweight process, right? We're just talking about posters. And this review should take about 15 minutes. But I found that it's incredibly helpful to start brainstorming sessions like this because it gets everybody grounded, right, and focused on the customer and their problem, right? It helps folks who maybe have a hard time staying on topic, for example, or might even have a different agenda. The mechanics of facilitating the brainstorming session that I've found effective goes like this. First, the data scientist as design thinking leader here restates the problem statement. You give people about 15 minutes to individually go and think by themselves and write down their ideas on stickies. You bring everybody together, and then each person shares their ideas while everybody else listens and builds on those ideas. Next, as a group, you organize the ideas into themes, and maybe collapse some ideas that are similar into one idea. Next, you review the criteria for evaluating a proposed solution, right? And then finally, you vote on the best idea. And what I like to do is give everybody 5 voting dots, because that avoids the problem of the loudest person in the room or the highest paid person in the room determining the outcome. Just some ideas to think about. Okay, so we're not done. The final step of the brainstorming session is to take the best idea and formulate a solution hypothesis. What's a solution hypothesis? Well, it starts with a succinct statement of the best idea. Then it goes on to list the leap of faith assumptions, the things that must be true for this idea to work. And then you identify cheap, fast experiments to test these hypotheses. In the data science project context, some of these leap of faith assumptions might be the availability of the data to drive the algorithm, the accuracy and speed of an algorithm. Is there such a thing? The feasibility of building the machine learning pipeline. So at this stage, we're at the end of the second stage of Design for Delight, and hopefully, truly, the project is our project. The third and final stage of the Design for Delight process is rapid experiments with customers. And in the context of data science, this generally means rapid prototyping and iterative development. So the role of the data scientist in this third stage is to do iterative development, starting from that solution hypothesis and getting feedback on each iteration from the customers. Right? They get feedback to stay grounded in the problem and the customers and the context. They also get feedback to maintain that sense of joint ownership. The solution, right, that's hardest to fall in love with and hardest to over-engineer is the paper prototype. So I love them and highly recommend them, right? As a data scientist, you can create a paper prototype even for a decision engine or decision support system or an analysis using storyboards and sketches, right? It's just emotionally so much easier to tear up, throw away, and restart a paper prototype, right, than even something that you've been polishing for a day. It's just incredible. So one thing that I think is a really important extension to the Design for Delight methodology is I find it's really helpful very, very early on in the project, in the data science project, to define a stable methodology and a stable data set to test whether algorithm A is better than algorithm B. Right? And to start with the simplest, dumbest algorithm you can think of as a baseline. This sounds so basic, it's amazing how many times it's not done. This is, I think, another great tonic against over-engineering and falling in love with your own solution, because if you start tweaking the knobs in your algorithm, you and everybody else is going to tell very soon whether you're reaching that point of diminishing returns. As a side effect, I don't know if you've observed this phenomenon, data scientists like to argue about algorithms, right? My wife has a term for this, but I can't repeat it actually. And so having an objective standard, to resolve algorithm issues, disputes is great. So I'm originally from Australia, and if we were in Australia, we'd say at this point, we're nearly home and hosed. Right? Which, if you're curious, is a racing term, horse racing. The horse goes around the track, and you take it to the stables, and then you hose it down. Right? So you've learned something today that nobody can take away from you. All right. So starting from a paper prototype, the data scientist iterates to produce these higher fidelity solutions, taking the customers along on the journey. And you'll notice that it's not a matter of working on the eye first and getting that perfect, and then moving on to the eyebrow and getting that perfect. What we're talking about here is creating an end-to-end solution very, very quickly. An end-to-end solution that includes a basic algorithm, some basic integrations, and basic UIs. Why? Because that's probably where the leap of faith assumptions are, right? If you want to try this at home, I already mentioned that Intuit has these almost ideal conditions that design thinking is already in our DNA. But what if you're in an organization where that's not the case yet? So here's what I'd recommend. Start small, obviously. Frame it as not a huge cultural change, but as a short-term, quick experiment. Okay. Model these behaviors, model this process in a small project, and get a joint win, right? And then get your colleagues to model the same behaviors and the same process in their projects. Whoa, excuse me.
All right, we've got about 10 minutes left.
You wish. No. All I was going to say is I hope you enjoy that. Thank you for your patience. I did do a deep dive in the process, but again, this is something I would have loved to have back in the day, so I just wanted to share it with you guys. If you do go away and try it, you had a fleeting glimpse of my email address. Please feel free to email me and ask me any questions. There was also a fleeting link to a handbook from Intuit on our Design for Delight methodology. So thank you for your patience, thank you for your attention. I'll be outside. Feel free to share your thoughts.